Hi guys, welcome to Unit 8, Lesson 3, Graph of a Function. So I have just a couple hints here at the top. There's a lot more information in your lesson, so make sure you read through the whole thing. Don't think that this is all that you need to take from it, okay? But a couple things to think about. Linear functions. Well, linear means line. Lines are straight, okay? So if a function is linear, you should be able to write it like mx plus b, y equals mx plus b. That is what we've learned, right? Slope-intercept form is what that's called, right? And with that, we can draw straight lines on graphs. Nonlinear, one hint about it, okay, is that it has exponents other than 1. Anytime you run into one where there's an exponent other than 1, that's an automatic red flag of, oh, this is nonlinear, okay? There are other ways that they can be nonlinear, but that's just one hint. For our examples today, the first one that we're going to go over is number 1 from your practice. It says determine if the point 3.75 is a point on the graph of the function y equals 0.75x minus 1.5. So all we're doing is we're plugging these in. Remember, with ordered pairs like this, the first one is your x value, the second one is your y value. So I should be able to plug x in, or 3 in for x, and have our final answer be 0.75. That's our goal, okay, to see if that works. So we're going to say y equals 0.75 times 3 minus 1.5. Well, let's see here. 0.75 times 3, I'm pretty sure is 4.5, right? No, just kidding. Goodness, I was way off. 2.25. Good thing I checked my work on the calculator. All right, Miss Angel's brain is somewhere else today. So this gives us 2.25 and then minus 1.5. Well, that does give us y equals 0.75. So in this case, the answer would be yes. Okay? Sorry about that. All right? Remember our norms. It's okay to make mistakes, right? Number 2 is number 2 on your practice. Determine if the given graph is the graph of the function y equals x minus 1. So, first off, I want you to notice that this is written in y equals mx plus b, right? Slope-intercept form. Now, m, that would be equal to the number 1, right? But otherwise, it's in slope-intercept form. So this is a linear function, all right, with the way it's written. Does this look like a line? No, right? It's not straight. It's curved, okay? So this one, the answer would be no, okay? It is not the graph for that function. All right, the last one that I have for you, oh my goodness, and I didn't even write down the number. Give me 1 second and I will get that for you. I don't know what I was thinking. This is from your quick check. And it is number 2. Number 2 on quick check. It says, which of the following is the graph of the function y equals x plus 2? So, I just drew like little basic versions of the graphs, okay? I didn't go into detail. They are more detailed on your lesson. But again, I want you to notice that this is written in slope-intercept form, which means it should be a straight line. Automatically, there are 2 that are not straight lines. This one and this one, okay? All right, and this one would not be a function. That means we're left with these 2 here. Now, hopefully right off the bat, and if you remember, so if I rewrite this, let's see, I'm going to rewrite it like this. I'm going to put a 1 in front of that x, which means that the slope is 1, positive 1 to be exact, okay? And if you remember from our work with slope-intercept form, If it has a positive slope, it should look like it's going uphill from left to right. Well, this is the only one where that fits, okay? So that's got to be it. We can't necessarily base it off of the y-intercept because in both graphs, it's the same, okay? But if you were to graph this on your own, it should look something like this, not this one, all right? So keep that in mind as you are going through. Everything that we've done this semester builds on this unit as well. If you need extra support, let me know. Otherwise, have a great day.